Bismillahirrahmanirrahim. This video is from chapter number 10 of Mr. Alexander and Sadiku's book on circuit analysis. And this question is on the request of a student from Saudi Arabia. And chapter question 1030. Primarily, we have to find this voltage here using mesh analysis. Let's see the question. Use mesh analysis to find V0, this voltage V0, in the circuit and figure. And the voltage of Vs1 is this value given, and Vs2, the second source, is 80 cos 100t. So as you know, this circuit is in time domain. To solve, we have to convert this into phasor domain. And first converting this source, this is the magnitude and this is the angle. So we'll only write magnitude and angle in the phasor domain. And similarly, the second one 80, and the angle is 0, so we'll write 0. Also, we know that omega is 100. From here you can see omega t. This is also omega t. So omega is 100. Therefore, we can convert all the inductances and capacitance into phasor by following this formula J omega L. So J omega is 100, and we put the value of L, which is 30 millihenry. That will be J30, similarly J20, J40. In case of a capacitor, this formula is 1 over J omega C, or it is also written as minus J over omega C. And you are putting the value, we get it to be minus J20. 200, sorry. So now our circuit will look like this. Everything replaced by the phasor values. And now we can solve it easily. So the first thing we do is mark the mesh currents. So this one is I1, calling this I2, and calling this I3. Then we should also mark all the voltage polarities as shown here. Wherever the current touches, that becomes positive. Current touching here first, positive. And similarly with this loop, current touching here first, it will become positive, positive, positive. And the third loop, the current touching this point first is positive, then positive, then positive. And now we are ready to write the KVL equation. So for mesh 1, we start from any one corner. So I start from here, negative sign, so we put negative, and this value 120/90. Then we come here, positive sign, 20 into I1, 20 into I1. And we come here, positive sign, J30 I1, but this current is going opposite. This is coming from top to bottom. I2 is going from bottom to top. We'll write I1 minus I2. J30 I1 minus I2 is equal to 0. And we'll arrange the terms. This will be our final equation. Arranging ones and twos, and then dividing by 10 or eliminating the zeros. So this is our first equation for mesh number 1. Now we come to mesh 2. Mesh 2, we start from here. The plus sign, again J30, but this time it will be I2 minus I1 because we are in mesh 2. So J30, I2 minus I1, and going here it's plus J40, and coming here we have minus J200, positive sign minus J200, and then it will be I2 minus I3. So minus J200 and I2 minus I3. Here also we can simplify, arranging the terms together and eliminating zeros. But this is our second equation. for mesh 2. Now we come to mesh 3. Start from here. And it will be minus J200. Now this time it will be I3 minus I2. So I3 minus I2. And J20 I3 and J10 I3 and then 80 0, angle 0. And rearranging again, so we get this is our third equation. So we have now three equations, equation number 1, 2, and 3. And if you look carefully, the easiest way to solve this equation is that we take help of matrix. Although there are other methods that you can follow. And writing in matrix form, we just write the magnitude. This is the magnitude of I1, magnitude of I2, and since there is no I3 here, so we put 0. And similarly, we write for the other two equations. So this is the determinant part, and then we have I1, I2, I3. And here we have the output. So J12 is 0 and minus 8. There is no point writing 0, so we just write minus 8. And now, to find V0, we have to find this voltage V0, and you can see there are two currents through this capacitor. One is I2, another is I3. So we have to find these two currents first to find V0. And we know the formula in matrix to find I2 will be delta 2 over delta, and I3 will be delta 3 over delta. Now, what is delta, delta 2, delta 3? Well, we'll explain. First of all, let's see, we want to find delta. So this is delta, and you can solve it by normal matrix method. You take this one and this matrix, and then you take the other one and the second matrix and the third. But this is slightly lengthy procedure, cumbersome. So I'll tell you a very easy way to solve this with the help of your calculator. We'll assign these values to our calculator, and let me show you the technique. This is our calculator. The first thing we'll do is clear everything that the calculator has in memory, and you can see this is the clear button. We'll press shift 9, clear, and all clear, so 3, and equal sign for yes, press AC. So now it is clear. Next we'll do is we'll go to the complex mode. We'll press mode and then 2 for complex. So we are in complex. And now where from we got these values? These are written here. You can see A, B, C, D, E, F, X, Y, and M. So these are 9 values that we can assign. So we have assigned A, B, C, D, E, F, X, and Y, M. So 9 values we have assigned to various variables. There is no need of assigning any value to zeros. Okay, let's start assigning process. 2 plus J3, we'll write 2 plus 3I. We don't have J button, but there's an I button. So 2 plus 3I. Then we press shift, and this is store button. So we press that, and then we press A. So you can see this arrow sign is saying it has A has been assigned this value. Then we press AC. We come to next minus J3. So minus 3I, and we'll assign this shift store B. This is B. B has been assigned. Now we clear. Then minus 3 is C. So minus 3 shift store and C. It's done. Then D is minus 13. minus 13, fifth store E. Sorry, fifth store D. So D has been assigned. Now minus 20 is E. 20, fifth store, and then E. So E has been assigned. J20 is F. So 20I, fifth store F. And here is F. F has been assigned. Then we come to 1 minus J18. 1 minus 18I, fifth store, and this we give value X. This is X here. X has been assigned. And J12 is Y. So 12I, fifth store, and Y, this is Y. Y has been assigned. And finally, minus 8, fifth store, and value M. So this is M. So M has been assigned. All values have been assigned. And now we proceed to the next slide. Okay, now for delta, we can write it like this. A, then this matrix, delta X minus FE, then minus B, and for this we have now C and X, Cx minus 0E, so there is no need of writing minus 0E, and then for delta 2, we shift the second column by the output. So this is our output. We have placed that in the second column, and we'll follow down the same technique. A, this is 0 minus ME, so A minus ME minus Y, and then Cx minus 0E, no need of writing that. And then we come to delta 3, the third column has to be replaced by this one. Third column replaced, and here also we write A, EM minus 0, this no need of writing, minus B, CM, this is 0, and then minus Y, plus Y, and this CF, this is 0, no need of writing. So I've written all three, and now when we solve with the help calculator, we should be getting this answer for the first case. So let's see that. Let's recall the calculator, and now we'll solve it as now. Initially we did not press alpha to get ABCD, but now we have to press alpha to get the ABCD. So this is alpha A bracket dx. Every time we have to press alpha. Alpha D alpha X minus FE alpha F alpha E. This one is done, bracket closed, minus BCX. So minus alpha B alpha C and alpha X. Since there is nothing else, so we can, there's no need of writing this bracket. Okay, so this is done. Now we press equal sign. This is the answer. Now this answer is in rectangular form. You can write that, but we need it in polar form. So what we have to do is we have to go into this mode, complex mode. We press Shift and complex. P for R theta, P equal sign. So this is the answer, 490.4, 490.4, angle minus 50.79, or we can write minus 50.8. So same way, we will now see these two also. A, alpha A, bracket, minus alpha ME, alpha M, alpha E, bracket close, minus YCX, minus alpha Y, alpha C, alpha X. We'll convert this into complex. Shift, there is complex. 3 for theta equal sign. So this is 52 under root something. So we'll just press SD. And now you can see it has 1096.94 and angle 28.0. The second one is done. Now the third one, ADM, alpha A, alpha D, alpha M, minus BCM, alpha B, alpha C, alpha M, plus YCF, plus alpha Y, alpha C, and alpha F. Equal sign, 928 plus 38, rectangular form, convert into polar. Shift, complex, 3 for R theta, equal sign, SD button, 1004.3 and angle 24.48. So all these three values we have calculated, and now these three values calculated, now we can put in the formula. I0 will be delta 2 over delta, so this is delta 2 and this is the value of delta, and by solving you can again clear. We go to this button, 101096.94 angle. Shift, this is the angle sign, angle minus 28, and then we come to the denominator, 490.4, shift angle minus 50.8, minus 50.8. We have entered all. Move ahead. Equal sign. This is again in rectangular. Shift complex 3. And the answer is, we press SD. This is not in proper form. So 2.23 angle 78.889. And then we come to I3. Same way, 1004.3, shift angle 22.48, denominator 490, shift angle minus 50.8, all entry done. Now there is a mistake, 490.4, 490.4, 50.104 angle and 3, okay, move ahead, equal sign, shift complex, 3, equal sign SD, 2.047 or 2.5, angle 73.28. So I3 and I2 we have found, and now we need to find this voltage. From here you can see this voltage is J20 minus J20 into I2 minus I3. So minus J20, I2 minus I3. We have put in this value, and this also will take help of the calculator to solve. AC bracket minus 200I bracket close, then bracket 2.23, 2.23 shift angle 78.9, 78.9 minus 2.05 shift angle 73.3, 23.3 bracket close, equal sign 4.931. This is the rectangular form. Convert this into polar by going to complex. P equal sign, you can see 55.149 or 55.15, and the angle is 35.4. So this is our answer, and the answer given in the book is very close. It is 56.26, angle 33.93, and this was done actually with the help of MATLAB. MATLAB calculates to accuracy of 4 digits, and that is why there's a difference, but this is the correct answer. I hope you have been able to follow this. Please let me know through your comments. Thank you.